Welcome to BAETTA International English, IELTS, GRE and ELT programs. This is Untitled Chairman ILT and Head of Linguistics, BAETTA Bangladesh. As a part of MA in English, ELT, TOEFL and TESOL curricula, today I am going to speak about test reliability. This is an innermost and pressing topic in language skills testing, evaluation and assessment course. So, this video is very important to you. Let's begin. Introduction. A test is an instrument, tool or technique to measure someone's knowledge, ability, skills, proficiency or calibration on a certain field, realm, arena or subject. Testing is the most important part in an education system other than approaches, theories, syllabus, materials and methodology. A test should be valid, reliable, objective and practicable as well as usable or implementable. The more similar the score of a measure on a certain construct would have been, the more reliable the test is said to be. Test reliability is very important in education, research, psychology, especially in teaching learning a language. Definition of test reliability. In testing and assessment, reliability is the actual level of agreement between the result of one test with itself or with another test. Test reliability refers to the extent or degree to which a test measures without error. It is highly related to test validity. Test reliability can be thought of as precision, the extent to which measurement occurs without any error. Test validity can be thought of as accuracy, the extent to which the test measures the hypothesized underlying construct. Basically, there are two major types of reliability. Number one, internal or calculative reliability, and number two, external physical or instrumental reliability. Internal reliability assesses the consistency of results across items with a test. On the other hand, external reliability refers to the extent to which a measure varies from one use to another. Example of reliability. Suppose you get your blood tested by a pathologist and the level of test shows that your blood level is 10.00. But without taking any energy, you took another test and showed that your test result is 15.00. It shows a wide gap between the two tests. It's unreliable, but not both tests. After 2 minutes, third test is taken and its result is 10.50. So, the first and the third test are consistent and reliable, but the second test is totally unreliable. In second test, maybe the machine or the pathologist was not accurate. In order to be reliable, certain conditions are to be fulfilled. If a test is taken at 10 a.m. and 12 p.m. another, in that case reliability cannot be measured because there is a big gap of time between the two tests and the result will be unreliable. Another example. Suppose you take 2 tests on grammar items. But in the first test, out of 100, you got 50 marks. But same test is taken after some days, but you got 50 again. The reliability coefficient is 1. That is called concurrent validity coefficient. In reliabilities, the coefficient is on also if 2 tests is 1 mark gap, reliability coefficient is 0.99. Reliability coefficient If there is no measurement error, the test may be 100% reliable, and in that case the reliability coefficient may be 1. On the other hand, if the test is totally inconsistent, then the reliable coefficient may be 0.00. That is a bad test. But there may be three kinds of bias that can affect reliability coefficient. Number 1, selecting different items. In two tests, same items should be selected. Number 2, time bias. In winter at morning and at noon, when the atmosphere is not so cold, this physical condition will impact on test. Both the tests should be taken in time. Number 3, examiner's biased. In case of subjective test or essay type test, two examiners may give different score based on their personal mood or temperament. Or if there is some nepotism, familiar students may be given more marks. Guys, now I'm gonna discuss how to measure test reliability or procedure of evaluating reliability of test. Actually, reliability is not a constant property of a test and is better thought of as different types of reliability for different populations at different levels of the construct being measured. In fact, reliability of any research is the degree to which it gives an accurate score across a range of measurement. It can thus be viewed as being repeatability or consistency. We can measure test reliability or procedure of evaluating reliability of test in the following 4 ways. Number 1, interrelated reliability. Different people, same test. Number 2, test-retest reliability. Same people, same test in different times. Number 3, alternate, equivalent or parallel forms reliability, where different people, same time, different test. Number 4, internal consistency or split half reliability, different questions, same construct. Now, I want to talk about it in detail. Number 1, interrelated reliability. When multiple people are giving assessments of same kind or are the subjects of same test, then similar people should lead to the same resulting scores. It can be used to calibrate people, for example, those being used as observers in an examiner or experiment. Interrelated reliability thus evaluates reliability across different people. Two major ways in which interrelated reliability is used are A. Testing how similarly people categorize items, and B. How similarly people score items. This is the best way of assessing reliability when you are using observation, as observer bias very easily creeps in. It does, however, assume you have multiple observers, which is not always the case. Interrelated reliability is also known as inter-observer reliability or inter-coder reliability. Examples of interrelated reliability. Two people may be asked to categorize pictures of animals as being dogs or cats. A perfectly reliable result would be that they both classify the same pictures in the same way. Observers being used in assessing prisoner stress are asked to assess several dummy people who are briefed to respond in a programmed and consistent way. The variation in results from a standard gives a measure of their reliability. Example 3. In a test scenario, an IQ test applied to several people with a true score of 120 should result in a score of 120 for everyone. In practice, there will usually be same variation between people. Now, I'm going to talk about number 2, test-retest reliability. An assessment or test of a person should give the same results whenever you apply the test. Test-retest reliability evaluates reliability across time. Reliability can vary with the many factors that affect how a person responds to the test, including their mood, interruptions, time of day, etc. A good test will largely cope with such factors and give relatively little variation. An unreliable test is highly sensitive to such factors and will give widely varying results even if the person retakes the same test half an hour later. Generally speaking, the longer the delay between tests, the greater the likely variation. Better tests will give less retest variation with longer delays. Of course, the problem with test-retest is that people may have learned and that the second test is likely to give different results. This method is particularly used in experiments that use a no-treatment control group that is measured pre-test and post-test. Here, practice, knowledge, experience, and maturity may affect the score reliability. Examples of test-retest reliability. Various questions for a personality test are tried out with a class of students over several years. This helps the researcher determine those questions and combinations that have better reliability. In the development of national school tests, a class of children are given several tests that are intended to assess the same abilities. A week and a month later, they are given the same tests. With allowances for learning, the variation in the test and retest results are used to assess which tests have better test-retest reliability. Now, I am going to talk about number 3, alternate, equivalent or parallel forms reliability. One problem with questions or assessments is knowing what questions are the best ones to ask. A way of discovering this is, I quote, do 2 tests in parallel using different questions. Parallel forms reliability evaluates different questions and question sets that seek to assess the same construct. Parallel forms evaluation may be done in combination with other methods such as split hub, which divides items that measure the same construct into 2 tests and applies them to the same group of people. Example of alternative or parallel forms reliability. An experimenter develops a large set of questions. They split this into 2 and administer them each to a randomly selected half of a target sample. In development of national tests, 2 different tests are simultaneously used in trials. The test that gives the most consistent result is used, whilst the other, provided it is sufficiently consistent, is used as a backup. Now I am to discuss split hub or internal consistency reliability. When asking questions in research, the purpose is to assess the response against a given construct or idea. Different questions that test the same construct should give consistent results. Internal consistency reliability evaluates individual questions in comparison with one another for their ability to give consistently appropriate results. Average inter-item correlation compares correlations between all pairs of questions that test the same construct by calculating the mean of all paired correlations. Average item total correlation takes the average inter-item correlations and calculates a total score for each item, then averages these. Split half correlation divides items that measure the same construct into two tests which are applied to the same group of people, then calculate the correlation between the two total scores. Experimental may select the questions randomly, or he may take questions of odd numbers for one set and even number for another. Cron vs. Alpha 1951 calculates an equivalent of the average of all possible split half correlations and is calculated thus. Average correlation A is equal to n into r minus bar upon 1 plus n minus 1 into r minus bar, where n is the number of components and r minus bar is the average of all Pearson correlations coefficient. The general rule of thumb is that a converse alpha of 0.70 and above is good, 0.80 and above is better, and 0.90 and above is best. Thank you.